doing at the Mysore Palace.
Wow, sir. That's nice.
Yeah. Right. Okay. So let us.
Hi, sir. Good afternoon.
Good afternoon, Somik. How are you? Krishna, how are you?
Good morning, sir.
Good.
Yes.
Good evening. Sorry, sir.
Divyang. Divyang, no? You must put your name on this one. It's easy to easily identify. Anka, yes. Anka from Hyderabad.
hi,
Yes,
sir.
there's a full quorum. So let us start today because it's a long session.
Okay.
The reason behind it is we are covering. Actually, we're supposed to cover 3 topics, but I'll be covering only 2 today. That itself will take a lot of time. Okay, this is unit 4 of the syllabus, which is on plant. There's a plant as in plant and machinery. First portion of the topic is on plant location. How do you decide on plant location and considerations? And the second one is on the plant layout. How do you do the plant? Of course, when we are talking now, when we say plant, obviously doesn't mean only for manufacturing, because whatever applies for manufacturing also applies for services and also meaning for any product, physical or otherwise. So that is what it is. And so I will start without much. Where is my? Yes. Okay, I will share screen. Yeah, this one, right. Okay, how did we? The cover slide as I should have changed. I don't know how. Yeah, it is. Okay, I'll quickly change that before we make. This is. Yeah, correct. Yeah. Unit 4 on plant. Okay, so that is the.
Sir, I have one request, sir.
Yeah.
Yes, sir. So can you share the syllabus of our this course, sir?
That is. Yeah, I have, but I'm sure you should have got it. But I'll send it to you after the end of the course. Okay.
No problem, sir.
Today, I have it with me, so आपका इसमें डाल देंगे, WhatsApp में डाल देंगे.
Yes, sir. No problem, sir.
Yeah, but today's topic, which I'm supposed to take, is unit 4 on plant.
Yes.
Out of that, as I said, there are 3 major topics, out of which 2 I will probably definitely be able to cover. Okay. So without much this thing, I'll get into it. It is on plant. It means plant location as well as plant layout. There are 2 things. Okay. Instead of saying plant, of course, we can also call it as facilities location. Now, why facilities is location is important? Because in a globalized world now, we know that even a single product, especially things like semiconductors, they are designed somewhere, the wafer is grown somewhere, the the etching and other things is somewhere, the packaging is done somewhere, the warehousing is done somewhere, and then finally it is distributed all over the world. If you talk of any product for that matter, pharmaceuticals, of course, India is a large manufacturer and exporter of pharmaceutical. Automobiles, again, something which we all understand. Automobile, not all parts are made in India. In fact, some of the parts are made elsewhere. Then it comes to various places within India and then gets into the assembling units, which are situated either closer to Delhi, or in near Chennai, Sri Perumbudur, where most of the automobile units are there. Or if it is two-wheelers, again, it could be in Punjab, or it could be in even in Mysore or Hosur or places like that. So we also talked last time when I met that there are typically minimum 4 tiers of manufacturing. So each tier from raw material stage to components to sub-assemblies to finished goods are produced across the world, and they are again distributed to the next stage of manufacturing. So now each one looks at where to locate the plant based on these considerations, which are you have to switch off your please. Hello, Soumik, please switch off your microphone. Soumik, yeah, right, because it disturbs everybody. So this only when you want to ask a question, raise your hand and then unmute. Okay. Otherwise, we'll prefer the questions towards the end, if possible. So there is factors which promote globalization of operations, regulatory and economic measures, reforms. Earlier, we were thinking that it is better that the goods are manufactured at places which are cheaper to manufacture. But what has happened in the process is that China took the advantage and then became the manufacturers to the world. This has resulted in a lot of problems, especially now with the war in Ukraine. You've seen that most of the countries have put a ban on Russia and China to an extent, because after our own skirmishes with China, we find that we don't want to deal as much as possible with China. But then that is inevitable, but we try to think. So in fact, we have tried to move in on that Make in India movement, which is happening from various places. So factors could be, again, the governmental such factors, regulatory and economic reforms, then factors, cost advantage. The main thing obviously is a cost advantage, because all said and done, ultimately we buy things because they are affordable compared to what is available elsewhere. We in this current regime, you cannot unilaterally impose import duties, high import duties, because of the World Trade Agreements. So we are forced to keep it at the level at which most other countries do that, and we have even reciprocal agreements with many countries. So the only advantage will be for you to make it cost with the least cost. So expanding markets in developing countries. So you want to either put up plants there, like we ourselves do, or Chinese do it, or the most of the other countries set up plants in the developing countries. Location issues have become more prominent in recent years due to globalization. Location decision pertains to the choice of appropriate geographies for locating manufacturing and service facilities in an organization. Especially if you see multi-product multinationals, like let us say levers. Of course, most of the products which are made marketed in India by a company like Procter and Gamble or Levers, they are all produced in the country, but then maybe a few of them are imported. And most of the products made in our country is also exported to nearby countries, because then you incur less cost for logistics and less time required for this. So that is why these decisions are done. Some of the reasons for location are also, like we discussed last time, that the semiconductor plant which is coming up in Mysore is purely for many reasons. Apart from the manpower availability in terms of engineering colleges and many other things in Karnataka. The biggest advantage is the water requirement is huge, and then that is offered only by thing. Obviously, Anka may ask, why not Hyderabad or somewhere nearby, where Godavari also can give water. But then there comes against the political decisions, and maybe because, I can openly say here that we have a BJP government, whereas you have somebody aspiring for a prime minister. So maybe that is also a decision possible. Okay, so there are combination of factors which determine the location. Now, there is a 3-tier model for competitiveness for a location. At the core of the if you see, there are 3 things. Like here, you have on the inner circle your company competitiveness, the ability to design, produce, and market products superior to competitors, quality, and business. But if you take things like this, say Apple products are designed in the US and produced in China and marketed worldwide. Now that way, Intel chips is most of the design are happening in India, Bangalore, but lithography done in Sweden and the wafers done in Korea, and across the world. So the competitiveness again, company competitiveness makes the primary reason for location. Then sector competitiveness. You see, what happens is we have in our country, there are certain sectors are highly competitive with respect to certain products. Like when it comes to automobiles, as I said, Tamil Nadu one section area is very competitive. That way, Haryana and Faridabad, that area is competitive. When it comes to chemicals and pharma, Gujarat is more competitive, that belt. And so once the certain sectors have more competitiveness available, then you want to put up a unit which needs the technology, manpower, resources, and many other things, manpower availability, all that. Then you tend to locate like startups for that matter. If most people come to Bangalore. Why? I don't understand. In fact, Hyderabad has equally as good setups. Of course, they are number 2. There is Pune. There is many other places in the country, because the startup ecosystem is very good, has been developed. It has not, of course, it has not been consciously developed, but it has happened over many years. So sector competitiveness in terms of labor, market flexibility, quality of infrastructure, quality of technology available, the extent to which a business sector offers potential for growth and attractive return on investment. That is the sector competitiveness. Next stage. Third stage is the country competitiveness. Again, here, we as a country have a lot of advantages. Maybe there are disadvantages also, but any person trying to put up the a unit or put up a facility or put up some service setup will look at the competitiveness of the country in terms of the country's own laws, which is the first one, government's budget and regulations. Quality of judicial and political institutions, how much there is a interference from the government and how fair are the laws. Because in that way, in India, we are far more transparent and equitable in the law. Openness to international trade and finance, extent to which a national environment is conducive or detrimental to business, and development of the financial markets, which is very, very important. And of course, in India is quite on top of that. Many people may not like to put up a unit in, maybe like if you ask openly, let's say our neighbor in Pakistan, because the stability of the country itself is under question, like even they themselves may not like to put it, Same goes with Sri Lanka. Sri Lanka is already now gone, financially. So but if when it comes to like South Korea or Taiwan and all that, they are flourishing places where it can be, Now, location decisions also are, if you take it, how do I shift it to, okay. The factors are market-related issues, cost-related issues, regulatory and policy issues, and other issues. Market-related issues is for the market, because anybody producing something would also like to have a good domestic market for that particular product or service. Although it is not necessarily true for all products. Like we have a PCB manufacturing plant in Mysore, which doesn't sell locally at all. The entire thing is exported. It's an Austrian company. Of course, initially started by Indal, but then taken over by the Austrian company AT&S. Again, PCB needs a lot of water, and this Nanjangud belt has that. Apart from, again, trained manpower and all that. In fact, Gandhinagar in Gujarat also has a lot of PCB plants, incidentally, right? But of course, the decision to put here was it is one of the largest PCB plants in the country, and there is no second. Although there are about 300-400 PCB manufacturers across the country. So, but that could be a major thing as long as the product is not only purely for exports. Then raw material availability is a factor which, especially in bulk goods, like if your main raw material is, let's say, steel or things like that, you would rather be close to a place where steel is available, because the logistic costs will be very high. Number and proximity of the suppliers, suppliers not only of the main raw materials and components, but also suppliers of all the services which go along with that for the operations, availability of skilled labor, quality of infrastructure. Especially when we say quality of infrastructure, the main things are the power. Today, of course, telecom connectivity is taken for granted, because almost across the country we have fairly good 4G, where there is no problem, except when you go for hilly areas and things like that. And of course, we are getting into the 5 also. The main thing are the roads, the roads and the power which is there. Water wherever it is needed, the quality of water. Cost related issues, wage rates, transportation costs, taxes, and other tariff issues. Wage rates is especially not only being, of course, today we have a minimum wages across the country. No organization can employ people without below the minimum wage. But more than that, what is the wages prevalent in that particular area? That's what people see. And what is the surplus manpower available? So that, and plus, of course, one of the major things related to manpower is that how much of unionism and many other things which are there. See, this is very important. Many places in Karnataka hardly has any unions. Like when you go, but whereas if you go to, whether it is you talk about Kerala or West Bengal, people don't like to put up plants there because of the high union, issues which happen, apart from the wages. Productivity may be higher, but the problem is again the things related to constant demands which come in, transportation costs, taxes, and other tariff issues, regulatory and policy issues from the government, which has stable and constant policies rather than, changing with every government. Fortunately, in India now, that doesn't happen. Irrespective of the government, most of our long-term policies are the same. There may be some small tweaking here and there when the government changes, but then nothing major. You can never expect any major change with any government. Quality of legal and other institutions, then trading blocks and trading agreements between the countries, and that is the thing. Main other issues are basically the climatic conditions, and one of the reasons why people choose certain places better than others. Sometimes the climate itself may be desirable for certain industries because you need high, let's say, humidity for a certain thing. Now, you can't put up a, let's say, textile mill in a place where there is highly dry and very low humidity, right? So similarly, there are many other things which you need to take into account as it comes to culture. Of course, is again, culture depends on many factors which affect the thing, and most important is the quality of life. Now, I will tell you in my own case, just to give you an example. When I decided about 40 plus years back, when I was in Bombay, now called Mumbai, of course. At that time, we were still Bombay. And I was looking out for locations. As I think I told you, that I was looking at Gandhinagar, which was one of the things. Pune was one of them. And one of the places in Tamil Nadu where my father said, I can get you lands and many other things. And Karnataka in Mysore. I found that among all these places, the quality of life in a place like Mysore, because obviously when you try to set up, you're looking at the family, then schools for the children, and your own recreation and other facilities, obviously, So you look at all that, and that singularly outweighed every other parameter. And if you ask your own people, they'll say, okay, I would rather go here than somewhere else, kind of thing. These are the issues. Location planning methods. You see, one facility with multiple items and location, the methods could be location factor rating, center of gravity method, load distance method. Multiple facility is the transportation model. If any of you who has done operations research will understand what the transportation model is. And of course, transportation model is also very used by Anand, the milk dairy, we call it as a milk run, where, the transportation is extremely, extremely important, because the time required from the time you get the milk to the thing and then processing, all that is very important. Now, center of gravity is something I'm sure you all know. If you are a student of physics, which you are even in your school physics, you know that when you take up the various factors, if you have various inputs coming in for the manufacturing a particular item, then you would one of the best things would be to put it where the center of gravity of all the items coming in is there. So the cost becomes least of transportation to the point of gravity. Okay, so these are three methods, and location factor method. This is identify and list down all the relevant factors for location decisions, establish the relative importance of each factor, rate the performance of each candidate location using a rating mechanism, compute a total score for each location based on its performance against each factor, and rank them. It's a simple ranking method, which you can do by yourself. When you give loading factors, you can yourself do on a point of scale of 1 to 10, kind of thing. How do you weigh this from a scale of 1 to 10? We always keep asking this. You can say, okay, 5, I will, no, it is very high on priority, it will be 10. In some cases, it will be not at all relevant, it could be just 1. So you do that and then say which location scores the best on that. An example is given here. Now, I will not go much in detail on this because, again, for want of time. Anyway, I'll be circulating this slide to you. You can go through this and then try to understand how it is. The factors which are, if you see, manufacturer of garments is actively considering 5 alternate locations for setting up his factory. The locations vary in terms of the advantages that it provides to the firm. Hence, the firm requires a method of identifying the most appropriate location. Based on a survey of its senior executives, the firm has arrived at 6 factors to be considered for final site selection. The ratings of each factor on a scale of 1:100. I said on a 1:10. It could be anything. It's easier to compute on a decimal scale. Provide this information. Further, based on some detailed analysis of both the qualitative and quantitative data available for each location, the rating of the locations against each factor was arrived at, and using this information obtained a ranking for the alternate locations. Availability of infrastructure. You give a rating of 90, size of the market, industrial relations, climate, tax benefits, and this one, availability of cheap labor, nearness to the port. Because garments he must be exporting, so obviously he's looking at transporting it to the nearest port. So in these 5 locations, out of this rating what was given, so some of them, let us say location 3 scored very high, and this could be subjective, but then you could arrive at a figure based on discussing amongst yourself. There's no sacrosanct, it is not a scientific, in terms of absolute figure, but you can always arrive at that one. So based on this, you have got the ratings for all these parameters, factors, and for each location, these are the things, figures which you have. And based on this factor, so with the multiplying factor which you have put there, so you can see that when you say 100, then the relative factors are here. See, this total rating is 325. So when you normalize it to 1, then 90 will become 0.28, etc. Put the relatives weight and the location, you will get a figure. Sorry. Yeah, you'll get a figure. And the overall score for the location, if you see that the location 5 scores first, location 3 scores second, and so on. Now, along with this, you must also obviously weigh the other factors like the climate, the culture and many other things, which probably has not been brought in here. The another method, as we saw, is the center of gravity method. This is a center of gravity, as you understand. If there is a heterogeneous, not a homogeneous, let us say, a heterogeneous object, how do you define the center of gravity? The point at which the object balances, if you say in a simple, in a college, we all have the habit of, rotating a notebook on our finger, right? We all do that. Now, that's very easy because a notebook is a homogeneous object, and you put this finger at the center of gravity and rotate. Now, if I give you an object, yes, yes. Whereas if I give you an object which is heterogeneous, which is the weight is distributed unevenly, you'll have to find a point at which you can still achieve it. But then that point, the center of gravity will not be at the center, but it will be at a certain point, which is determined by some equation like this. So all the demand points is supplied, are represented in the coordinate system. Cartesian is nothing but a cart, XY. So each demand will also have the weight indicating the quantum of shipment. Therefore, it is possible to identify the center of gravity. So using a certain formula, you can then say that taking all this into account, this is the best location to put, which will have the least cost. Here again, he has given you an example. I will not go into much detail of this. You can go through it when you get your sheet to you. So based on these factors which are given, identify the most appropriate point in the grid map to locate the new facility. So in this, of course, this is a Cartesian thing, distance in kilometers, and then he has found that the center of gravity is in this coordinate, the best point. But of course, there may be other factors, it may be on top of a hill. It doesn't mean that you'll have to put it there. So you have to take into account other factors to go nearer to the point of feasible location within nearer to the point of gravity. Load distance method enables a location planner to evaluate 2 or more potential candidates for locating a proposed facility vis-a-vis the demand or supply points. So provides an objective measure of the total load distance for each candidate. Something like the center of gravity method, but this takes into account the supply and demand. That means the materials coming in, the materials going out. And where are all the points from where it is coming in, the points at which it is going out. So each is a load. And then based on these center of gravity calculations based on the load, there you calculate. Okay. So here again he has given an example. And so what is the best location for the proposed new facility? You can calculate using that formula. And if you see that this number 1 has probably, I think, the lowest or something like that, you can see. So the solution here is in the load distance method. The candidates for the proposed facility are here. Existing demand is here. And where is that? Okay. 1, 2, 3, 4. Supply points. I think the solution in the previous one gives these LDJ values based on the highest point, which probably is 2, which gives the location. In a multi-facility location, as we said, in the first slide, the transportation model works. Now, let us say that the same Hindustan Lever or something, making the same product, let's say the noodles, is being made in, let's say, 5, 6 locations across the country. Now, if they want to do that, they will determine which are all the locations based on the places from where, the transportation of materials from raw material to the plant and the finished goods to the warehouses from where it is distributed becomes minimum. And the transportation model is again a mathematical model. And as I told you, any of you who have done operations research kind of table will be able to work out. And there is a locating distribution centers for nationwide distribution of products. Typical example belong to this category. Usually they use it for this because where all they should keep. Today, retail is the biggest business, especially when it comes. Of course, the 2 big people are Reliance and Amazon. And when these people locate warehouses, they try to work on this transportation model because every pie counts, in this. What is the cost? Because the end price for a person sitting anywhere in the country is the same. So where they become cheap is only when their logistic cost is lowest and the material is able to be reached within the lowest possible time. Like if you're an Amazon Prime, let's say, customer, they promise you delivery within 24 hours. Now, how do they do that? Those products which are again sold as Amazon Prime are available in the critical warehouses from where they ship it to you, and they make sure that they ship it from the nearest location, from the ordering point to that. Even if I'm in Mysore and I create an order at let's say 9 o'clock, 10 o'clock at night, I get the material tomorrow, next day by afternoon. Now, how is it possible? You can say, but then that's how the entire system works. The warehousing works 24 hours thing. There are multiple uh, transports happening throughout the day, and they calculate, let's say, 4 hours of transit from this to this, coming to the local distribution point, and then deliver to you. So the transportation model is something very important. I think somebody's mic is on. Please switch off.
Yeah, sir. This is Ankarao.
Huh?
Ankarao, this is. Sorry.
Yeah, Anka. Yeah, please switch off.
Yeah.
Yeah, if you have a question.
I just wanted to share one thing.
Yeah, please. Yeah.
So regarding the transportation, so I have recently ordered, when I was in Bengaluru, I just ordered one of the sneakers. So there is one option saying that you would like to take from the nearby shop, or you would like to courier it.
Yeah. To your that option also they give. Correct.
Yeah. So instead of going for a delivery centers again, so they are directly delivering from the shop to owner.
Yeah, correct. Yeah. See, there are various.
So even the transportation also becoming little vary now.
No, there are even one more option where you can go and pick it up from the nearest place.
Yeah.
That is,
yeah.
That place is not necessarily their own warehouse. It is a third party. He could be a milk vendor, or it could be
anything.
Yeah, it could be a small shop and things like that. No, that's a point from where you could pick up.
Yeah.
They want to ensure that you get it at the shortest possible time. See, ultimately, in the transportation model, what is important is from the point of demand to the point from the point of supply to the point of demand.
Yeah.
It should reach within the shortest possible time.
Okay. So one more doubt regarding the plant location, so which we are discussing.
Yeah.
So this could be same for the services industry. So it will be different.
No. It need not be. It need not be, because again depends on what type of service you are talking about.
So if we take IT services, suppose. So
IT services, see, basically, if IT services, your entire delivery is happening on the net. There the question does not arise which part of the world you are in.
True. Yeah.
There the other considerations will come into the picture. But whereas suppose you are now trying to locate, let us say, a hospital or a hotel in a city.
Okay.
Or a car service center.
Okay.
Then the location becomes very, very important.
Okay.
So the weightage for a location may be different for different products and services. Yeah.
Okay.
Certain things are more important in like say services, where because the culture is important, the quality of life is important. Now, why don't people go and do work in rural areas? Because the IT crowd wants a good life for their weekend. They work five days. Literally 15, 16 hours, and then at the weekend they want to have a good time. Now, whereas that's not available in, let's say, if you are situated in Dodbalapur or something, you would rather be in Bangalore rather than Dodbalapur, correct? Or in a major place where it is available. Right? One of the reasons why Bangalore scores over that is because your quality of life is much better. Although I would contest myself, because it's a very highly congested city. I prefer Mysore than Bangalore. For me, quality of life in Mysore is much better than quality of life in Bangalore. But that's a decision which a lot of people take, because even in fact, today I met one person who works for IBM. Now, IBM is trying to set up a small facility in Mysore for their services. Now he's opted to come here because he finds the quality of life in Mysore is better because he has married with the 2 kids. Now there are international schools in Mysore. There are things now. The transportation time is very less. Whereas in Bangalore, even my son takes 1.5 hours to reach his office one way. So it's like 3 hours in a day goes for going from to office and coming back. Now
Yeah, right.
that's not a quality of life which you would want. But if you're
Yes.
given a choice, obviously people would like to get to their place. So factors like this are very, very important for each type of product or service. That is very important. That is why even large companies, when they try to set up on remote areas, they have to provide all facilities. That is, they have to provide a township, their transportation, their entertainment, schools. You see, just like the Tatas, I know for a fact that the Jamshedpur was developed as a city long back. When Tisco came up, then Telco also came up. There, it's a full-fledged township. Most of the places in the east, especially Bhilai or Durgapur, all the places, the entire city is created. That is exactly what China does. What they do in China is they develop an entire city or a town, before they move businesses to that place. The same model is followed in Gujarat. I forget the name of that place where in the not Anand, of Anand. Sanand. No, Sanand, Gujarat. उसमें नहीं that name of the place is something else. उसका जगह का नाम जो है correct, Dolera, you are right, Divyang, you are right, it is Dolera is such a facility like that what China was doing. Dolera is being developed as of now. Not many people know about Dolera, but the city is being developed in such a scale that once it is developed and now all that bullet train, many of those things will start coming up. You'll find that the people opting for that location will be very high. There are many, many locational advantages. In fact, the government should do this, that infrastructure development where taking into account the type of products and services which will need those facilities, those need to be developed and people will automatically come, there. Of course, Divyang, you're right. The Dolera is the place, I forgot the name recently. Okay, now this is the mathematical calculation using the transportation table. If you see the weightages and other things, for each one of them, the warehouses are there. Then you locate the plant accordingly. Other issues, the international markets, there is a shift towards fewer facilities that could serve markets worldwide because of quality and other issues must be availability of certain critical material. That could be one of the things. So availability of good transportation infrastructure, use of internet and IT services, location planning is an overall context of just-in-time manufacturing philosophy. See, basically what is happening is in manufacturing and especially in many, in most manufacturing, people don't want to hold too much of inventory because inventory means there is a cost and cost of, and it defeats the economy of economics fully. So if you want to be just in time, then you have to ensure that every supplier who is supplying to you is able to give you within the shortest possible time with the least logistics time, basically. So this again mandates that you are situated near the point of supply, kind of thing. So service quality depends on the responsiveness of the service delivery system. Locating service outlets close to the demand point is important. In case of services, yes, obviously, other than, of course, IT and other things where your service is being provided on the net. In all other cases, it is that your service delivery has to be nearer to where the customer is there. So location issues have become more prominent in recent years on account of globalization of the markets. Multinational corporations have more opportunities to identify candidate locations for their manufacturing facilities. Factor cost advantages and expanding market in developing countries have made these nations attractive. So we ourselves are now trying to attract people from across the world, and each state is now competing with other states in trying to attract investments. Of course, the joke is apparently even, of course, Mamta ji also is trying to attract investments in West Bengal, but I don't know how far she'll be successful with the kind of there. Yeah. Simple qualitative methods are useful for quickly screening an initial set of candidates and narrowing down to the choice of one or two. As I told you, in my own case, I had 4 points. I spent 6 months, you won't believe it, on location alone, to finally decide on location, because location decisions are like, are permanent decisions. You cannot continue, keep relocating your facility here and there. You grow roots, as we say, once you go to a particular place. So, in fact, I've seen that many of the companies, even in Mysore, people who come from all over India, once they come here, they don't want to go back to their original place, because they've grown roots here. They become almost like, accustomed to the local conditions. Living conditions here are much better than other places, and think. So this is what a person would see, even if you want to opt for a transfer or something like that. I've seen companies like where Larsen and Toubro, there are executives who come from, like, say, Bombay, they come from Gujarat, or come from up north in Delhi. After working for 7, 8, 10, 15 years, now they tend to settle here because the quality of life is much better, that kind of thing. So, but there are some people, I know a person who said that he's not going to live in Mysore for the simple reason he's a fish eater. We don't get good fish here, either a freshwater fish or sea fish we don't get easily in Mysore. He says, no, I can't live here. So each person has his own considerations also in these factors. So Saumik is laughing. So it's like, I'm sure he's a fish eater, right? Right. Okay. So now we come to the next stage, which is the layout planning. Once you have decided on the location, right, then you have to design your facility, how the facility will be, you may have a total area, but depending on the process which you adopt. I think yesterday you talked about the process and process design and all that kind of thing. So once a process is designed and then there is a process flow, then each process needs, again, within the facility, the layout has to be planned in such a way that there is, again, a very optimal flow of goods and movement to ensure that there is no crisscrossing of material, crisscrossing of manpower, or unnecessarily movement of materials or equipment, measuring, whatever, kind of thing, or sampling for quality and all that. Recently, I had gone to, Dodballapur to see a PCB plant by BPL, single layer PCB plant. I was quite amazed that, a lot of people produce PCB in this country, maybe 300-400 manufacturers across the country. They are one of the top 10. And recently they have done the entire automated line, and it very beautifully laid out. I think it's a modular flow of processes across the first and, on 2 floors. The right from the raw material goods and brute storage to inspection to the initial stage of the process to etching, all that kind of thing, it's a smooth flow, absolute smooth flow. There is no crisscross anywhere. And finally, it comes to the finished goods. I said it was so small, the finished goods stores. I said, "What? You don't have material? Material? No, we don't, because the moment it is the goods are produced, it is within a day or two, it is shipped. So maximum 1 or 2 days of production only we'll be having in the finished goods. It's a very streamlined and good flow, and you feel nice to see that kind of facility. So the planning of layout is extremely important, and there are many ways to do this kind of layout planning. Now it is true for whether it is in manufacturing or in service. I'm sure some of you who have gone to do some work with the banks, of course, nowadays you hardly go to a bank for doing any work. I'm sure you will find that in some of them you have a good experience. And in some places, you have to crisscross between one fellow, that fellow. He says you go behind, go to that department, this department, and then all over the place. Which typically happens in government offices. Yes, but in any of the other places, even in service organization, whether it is hospitals, is most extremely important in hospitals. This is again a service organization. How the whole thing is laid out, right from registering for a patient to going to the different services, and then some of them, like let's assume that an X-ray service is centralized. Now, the X-ray service may be needed for a cardiac patient, or needed for a dental patient, or it may be needed for a foot related problem. And if these departments are in different places of the hospital, and then every time they have to crisscross and come, it's not a good layout. Only certain, now in most hospitals, what they do, they localize most of these services within the department, except certain very major things like MRI. MRI is something every department cannot have. It's a huge facility and put. So the location of the MRI will be in located in such a way that it is easily accessible for all the departments. Also, it's a huge hospital. Now, I can tell you, we have one of the largest private sector hospitals in Mysore. You will again say, is one of the things. It's a JSS Jagadguru Shivratri Swamiji Hospital. It's amazing to see the kind of the layout there. It's so many departments, so many doctors. Thousands of literally doctors in hundreds, and departments and facilities and going. It's a smooth flow. Which goes. The number of patients must be coming in thousands every day. So the layout is extremely important for an input, process, output. See, when you talked about yesterday, the process is defined as input, process, output, and the main process is again divided in sub-processes. Each sub-process has an input and an output, and the proximity of the input and the customer for the output for the next process is important. It should be ideally like a relay race. If you have seen a relay race, 400, let's say 4 into 100 meters relay. Now, most of the cases in a relay race, the team which is able, it's not the fastest running athlete will win the race. It is the team which is able to change the baton most efficiently will win the relay without taking time from one to the other, or the dropping of the baton, or whatever, all that kind of thing. So the working of the entire thing, or you can even imagine an orchestra, where there are, let's say, 40, 50 instruments and then performing, Now you'll see that they are very right from bass to treble to the violin or the wind instrument. They're all placed at places in such a way that you have a consonance on the ear. They'll not be placed haphazardly. So that is why you get good music. That's why I say that you want good music, it should come, you should be able to appreciate the sound coming from various places. So similarly, the layout in any facility should be like that orchestra, where how it gives you the best music, or a facility which gives the best output without having to crisscross from one place to another with the least travel and the least amount of effort. So layout planning in manufacturing service organizations deals with physical arrangement of various resources that are available in the system, with an objective to improve the performance of the operating system. Benefits of good layout design: jobs in a manufacturing system travel lesser distance. See, again, the emphasis is on distance. Customers spend less time in service systems. Costs and lead time come down. Improved quality. So types of layout, there are 4 types. We'll discuss them in a little depth. One is the process layout, arrangement of resources on the basis of process characteristic of the resources available. Like, let us say, a chemical industry. Now, the process layout is designed in, it cannot be done haphazardly. It works continuously, or steel manufacturing for that matter, or cement manufacturing. These are typical kind of works. The input to output is, again, it doesn't wait. There cannot be a waiting time. There cannot be an inventory in these kind of processes. The output is immediately taken for the process for the next, it's taken to the process for the next, and then it just goes on. And it's a smooth unidirectional flow. Typically, process layout is something like that. A product layout is the order in which the resources are placed follow exactly the visitation sequence dictated by the product. Product layouts, like suppose in an industry which is making different varieties of products, they could be having different assembly lines, kind of thing, for the different products, with certain centralized facility for some of the key, like painting can be done probably in a centralized facility, but then different assemblies can be done in a layout like a product layout. Group technology layout seeks to exploit commonality in manufacturing and uses this. This is where, like we say, we talked about we're in an automobile, the painting has to be centralized. All the components for painting has to come to the paint shop because it's highly corrosive, it has highly toxic and thing. It needs a special care. Some of the products may be done in what you call as a it is also called as, I'm just trying to get the name, where in different groups, like it may be making brakes in one division, the clutches in another division, so they have their own layouts because they need typically different type of processes. So group technology layout is, could be one of that. And fixed position layout. Emphasis, see, it is like, let us say you need very high presses, 400 ton presses, 100, 200, 400 ton presses. No, you can't move the machine from one to another. The product has to move. So there are some specialized welding, let's say, which again needs a huge fixture. So the machinery is fixed and the products will move depending upon the requirement to that particular place. Emphasis is not so much on the optimum position of resources, since the product itself largely dictates this. The focus is on gaining better control of the material flow and reducing delays. So we'll get into a little detail of each one of these. Volume versus variety, implication of layout planning. So we see in this table the flow attributes, in the sense, how does the process flow? You saw yesterday what is the process flow. Usually a product of mass manufacturing. Let us say you're making coffee or steel or cement. No, there are not too many types of cement being made in one day. It is only one type of is made, and then it's bagged, and so many bags and so many metric tons of cement are flowing out. There can be a streamlined flow, a medium variety of things like, let's say you are making toothpaste kind of thing. You may have 4 or 5 different types of toothpaste in three different sizes kind of thing. So that could be, the flow can be a little different, medium flow paths. High variety, where there is a total disorganized flow. When there is very high variety, the change from one to other itself will need changes in the machinery. So the kind of technologies like single minute exchange of dies and that kind of thing will come into picture, where there is a high variety of change that is needed. And one-off execution, where you have, let us say, 10 different type of machines with you, but each item may not need all the 10. It may need only 3 or 4. Some may need a lathe, it may need a drilling machine, it may need a welding, it may need a tapping and filing and other processes, and then finish and send. The another process may need something, a different set of processes. So in this, the machines are located fixed and the product moves in a jumbled way depending upon the requirement of that particular process for that particular product. Usually low variety, high volume, mid variety, mid volume, high variety, low volume of each one of them. Totally the volume may be very high, but for each of the variety, the volume may be very low. And one-off execution is like one piece by one piece, or maybe 10 pieces, 20 pieces, that kind of thing. It's not very high volumes there. Examples of operating systems. So here it is usually for process industry, mass products or mass service providers. In medium variety, we use what are called as a batch manufacturing machines. That is, you produce, like let us say there are 10 different varieties to be produced on a given day. You schedule the process in such a way that the first 1 hour, 1.5 hours, you produce one variety, next half an hour you produce this, and the next 40 minutes you produce this, that kind of thing. So they are batch productions. When there is high variety, they are called as job shops, customized product or service provider. And one-off kind of a thing is a project shops. Types of layout used, usually when there is a high volume production, there is a line layout. Product comes from the, like somebody said, either say aloo dalo, udhar se something will come out. Is there somebody said, no, either say aloo dalo or either se kya nikalta hai? आलू का चिप्स निकलेगा ना, और क्या निकलेगा? Correct. So right, but then that is a single flow, उसमें ज्यादा day in and day out, morning to evening, they'll be producing only, and then put them in packets, lays. Maybe at the end of the process, there'll be different flavors coming in, and you pack them. In medium variety, the group technology layout is usually used. In high variety, you can have a process layout, and in one-off execution, there is a fixed position layout. This is very important for you to understand, because what type of a product and what type of a service you are offering and how do you define and design your layout is extremely important. For I remember when I established my unit about, say, 42 years back, even for designing my own, the facility, the building, I had to tell my architect, that this is my process, this is how the machines will be placed, this is my capacity, so many machines of this will be there. I was using a batch process. See, it's a medium variety. So this thing comes under this batch process. Batch process in the sense that there is let's say 5 different processes, each having different varieties again within that. But that set of machines are there. For another reason why batch processes is because the process itself, the employee gets trained to do that particular process, and he's able to handle those machines more effectively than anybody others. So the batch process is the one which was most suited for what I was doing. I couldn't establish a different line. But at the same time, suppose I had a high volume of demand, I would have probably gone for a line layout. For each one of I have 4 basic varieties of product which I was producing. But within that, the sub varieties are very high. So I had to go for a batch manufacturing layout. Whereas I've seen in Japan, they're having a line layout for the thing, because there for the morning to evening, that the concept itself is different. Each firm does not produce all the varieties. So they distribute their production to different facilities, so that one produces the same thing throughout the day. So their economics becomes they become much cheaper, and they're able to turn out a lot more production than we doing. But then in India, we don't have that kind of volumes. So we had to do a batch processing. In a process layout, let's say, this is a typical diagram of a process layout. Product A, lathe, L could be lathe, D drill, grinder, milling. So they've just put the names, but I can say that, being an engineer, I'll put L as a lathe and D for a drill machine, G for a grinder, and M for a milling machine. Okay, so a product A travels, suppose this is a dotted line from lathe 1 to drilling machine 2 to it doesn't need the grinding. It goes to the milling machine, and from there it comes to the grinding machine and then comes out. Whereas a product B may need a lathe and then a drill, and from there to go to a grinding machine and then come out. It doesn't need milling. As I said, product C can be you just left it out. It could be something, where it happens from this to drill to milling to again lathe and then come to a grinder and then goes. So the requirement for the processes to happen for different products are different. So there is all the lathe machines are in one area is a process. All the drilling machines are in one area. All the milling machines are in one area. All the grinders are in one area. And the flow of material depends upon the process, and it happens this way. So this is typically a process layout. Okay. In a product layout, example is that the same thing could be, suppose your volumes for each one of them are very high. Instead of having a process layout, You could have a line layout. Same product A, we saw that in the previous one, it went to a lathe machine, to a drill machine, to a milling, to a grinding, and then out. Now, I could have a dedicated machine for each one of this in such a way that I do 1, 2, 3, 4, and then go out. Now, this is a lot more efficient, provided I'm able to load. You see, ultimately, what are the considerations in manufacturing? That there should be maximum utilization of the equipment and the manpower for each one of these. Suppose I take, let us say, now considering this takes 1 hour, whereas this takes only 10 minutes. This milling is a very slow operation. This may take 1.5 hours. And grinding, let's say, takes 20 minutes. Now, if you see the throughput will be determined by this 1.5 hours, which is taking the maximum time. But machines are not fully utilized, manpower is not fully utilized. But there is a way of doing the layout by line balancing so that, you have more milling machines put across here so that the product moves in such a way that the time taken will be, say, let us say 20 minutes uniformly across the whole thing. That's one way of doing it in a product layout. So like we saw that product D could have this kind of a thing, product C could have a thing. This, of course, is not there in the example given, but I'm telling you that this could be a problem. So we do that by what is called as a line balancing. Then this is an example given in a bank, because we talked about a bank, right? A bank A, you enter, there is a waiting area. Then there are different departments. There is a foreign exchange department. There is many, of course, immediately there is a receptionist who attends to you. And then the credit section, then the operations area. Then you have the main manager credit. Now, why they put credit in this thing is they are not going to give you money, that's why they put you in the back, I think. Whenever you ask for a loan, they'll say no. So easier to put it out there. And then you have a conference room and the person who is heading that facility there. And some other common facilities are here. This could be one kind of a thing. There could be there could be another kind of a layout, Generally, what is happening is now, which is more being practiced, what we call as a railway reservation system. I don't know whether you have seen the token system in railway reservations. I think that it's a very efficient system. I don't know whether I've seen. Of course, now nobody goes because I book through it. I see IRCTC. Nobody goes to a railway station to book tickets. But in the good old days, when you used to go, there'll be hundreds of people. Of course, when people now who can't do it online, they still have to go to the station to book. There's a long line. So what do people do? If you wait in one line, you'll find that that person is very slow, or the moment your turn comes, he has gone for chai or thing. It's so frustrating. So to avoid that, what they do is that sometimes they give you a token. In many of the banks also they do that. In many of the telecom companies also, when you go for service, they'll give you a token. And whenever a person is free, that you'll be called to go to that. So that way, what happens is the time taken is the least. So that's an ideal kind of a layout for service in that. So you have to design facilities in such a way that these kind of things are. Of course, limitations on the layout is there, limitations on the facility available is there. And each bank, each hospital, each hotel has its own way of arranging those facilities. Process layout, disadvantage. Types of fixtures required, there are more, like I said, yes, use the correct drilling, milling, turning, grinding, gear cutting, whatever. Okay. So the distances from there is important. Time to collect those fixtures because, yes, Divan.
Yes. Sir, bank layout pertaining to which type, sir?
Bank layout depend. See, basically, it's a job. What we call it as a job shop. I'll tell you why. You go to a bank only for one type of service. You don't go to a bank for maybe maximum one or two operations. Like even today, the passbook is also automated, right? You either like to draw cash, or you want to deposit cash, or you want to go on to a manager for asking for a loan, or if you are in the thing, you have a specific type of work to be done, and that specific type of work is done by a specific officer. So this is what we call as a job shop. The last one, the project kind of a thing which we saw.
Project layout. Yeah. Why? Because you are only there going for only one job. Each customer is going for a different. But there again, within that, for cash, it becomes a line layout, because there is
Understood, sir.
yeah. So it is a sort of a mix of all this, but typically it's a project, layout. Yeah. No, it can be within that it can be fixed. It can be different things. The criteria should be of trying to service maximum customers within the minimum time in whatever process, because that is what is going to give you the least cost for operations. So that is the consideration in whatever you're doing. So layout design performance implications we have seen. Of course, this is in the previous thing. Oh, sorry, we missed that. This is the one which we are talking about. So the calculations are based, on the kind of time involved, as I said. And one of the techniques to resolve this is by balancing, what we call as a line balancing. Probably it will come later, but I'm telling you now, the line balancing as a technique will come a little later in the course. The advantages, disadvantage between process layout and product layout is, in process layout, the sharing of specialized and costly equipment. You see, let us say we talked about this MRI in a hospital. Now, each department cannot afford to have an MRI. No, as it is, the hospital, even a big hospital may be having 1 or 2 MRIs only, right? So that has to be a process layout. But X-ray machines they can afford to have. Every department can have its own X-ray, specialized X-ray machine. So there it can be a line layout, whereas when it comes to MRI, it can be a process layout. Where there is more flexibility, you can have process layout, less vulnerable to breakdowns, because in a line layout, you have to ensure that all the machines are working, throughout the day. Because if one of them break down, either you have to move in quickly another machine, or have it quickly repaired. I've seen this happening also. In fact, in a line layout, the operators in a Japanese factory, I've seen how the operator itself is carrying a lot of spares. Spares is there on their own workplace. The moment they know that something is malfunctioning, they stop, and it is like that Formula 1 racing, where they remove and then put, changing a tire and that kind of thing. They do it in a fraction of seconds. They remove that, put this, and then continue operations. There, because of the high volumes, they can afford to do that, and the people are trained. But in a place like India, the moment something breaks down, you have to call an engineer, a maintenance engineer. This guy may not be trained to do the job himself. So there the problem happens. Then the process layout is better than a product layout. In a product layout, the standardized product or process routing. Operational control is very simple because it's a line flow. It's a linear line flow. High output rate is possible because from end to end, as I said, line balancing, once you do, it is that the machine which has the bottleneck, which will be the throughput. And that is other processes are balanced to ensure that the output will be the bottleneck output. Disadvantages of process layout, large inventory buildup. Because like if you have seen MRI, like I've gone recently, I went to Narayan Hridayalaya super specialty to take my wife. Because I knew the medical director, I could get through. But then I've seen that you have to take appointment for taking an MRI. Unless you are an emergency case. He said you will get it on Tuesday at 2 o'clock. That kind of thing. Right. So the buildup of inventory is very high. In a process layout. Operational controls are difficult because each operation has to be controlled by specialist people. Excess material handling, people are waiting, so many people are waiting if it's in a service, and then material from different parts of the processes have to come to that facility and then go back to the next process, all that. So in a product layout, there is a low tolerance for breakdowns because, as I said, if one machine breaks down, the entire line comes to a halt. This typically happens, but then, as I said, you have to be very quick in doing that changeover. Like gave you an example of Formula One racing. How they do the moment I don't know. Have you seen a Formula One race? Didi? Formula One race.
Yes, sir.
देखा है वो pit
Yes,
stop
sir.
वो pit stop बोलता है ना pit
Right.
stop में क्या करता है वो once the vehicle comes there within 10 seconds or less than 10-20 seconds all the
Everything
tires
is
are changed.
completed. Yes, sir.
Everything
Right.
is done and then they continue.
Like quick service is done within
so
just 10 to 15 seconds.
Who does it faster? That person will obviously win. Just like in a relay race. Kind of
right.
thing.
Right.
So here also the breakdown, when it happens, you should be able to immediately bring it up, without waiting. So duplication of equipments are there, but then you see generally when these equipments are not costly. See, today the manpower costs and loss of output are more than the equipment. You can afford to buy, especially like as I was telling you, the difference between an X-ray machine and an MRI machine. X-ray machines are available for 30,000-40,000, maybe, small thing. MRI costs in crores. You can't have a line layout for an MRI machine for each department, whereas you can afford X-ray machines for every people. No. Duplication of equipment leading to high cost, less flexibility due to dedication of resources. Yeah, because you can't move from one place to this equipment to one place to another that easily. So group technology, cellular technology. Yes, I said I'm not getting that word when I talked to you earlier. It's also called cellular technology. Of course, इसमें नहीं लिखा है, but फिर भी, the moment I saw this word cell, it just came back to me. Group technology or cellular technology is that the product group itself is a line layout within a particular cell. And such cells are formed. I've seen such layout in TVS company, not TVS company, it's a Sundaram Rane Madras, yeah, a company which makes clutches and brakes and things like that, So they have a cellular manufacturing which has different machines which are there producing the kind of, it's a line layout within a product layout, kind of thing. So it's a group technology process. Most people use this because suppose what happens, the advantage of this is there are 4 products, let us say, in the previous case. Iska demand kam ho gaya. So they can afford to stop this and move the people to the different other places. You see, they don't have to incur running costs on this. Or they can change the cell itself, the number of machines here. Suppose iska demand double ho gaya. So they can create another cell. By closing this cell, they can create one more cell for this.
So cellular technology is something where there are more products, multi-products, but not too many variety, maybe about 3-4 varieties, but then they have machines which are laid out in this way. Fixed position layout is where some of the very big machines, as I said, it could be 400-ton presses, it could be a huge painting base, or it could be specialized welding where things cannot be moved easily from one place to another. This is an example, but I do not know whether there is not expansion of this example is not given. So where a facility is fixed and then the product moves across to that facility. Layout design implications, of course, you can calculate this way average distance traveled and all that, and then change the layout to suit the minimum distance traveled. Layout design performance measures, distance is there, space utilization, especially in places in big cities. Space is like typically if you see, like, I don't know, Mumbai, they have manufacturing in even in industrial areas within the city. Now you get to get even 1,000 square feet of space is very expensive. But then they ensure. I've seen my own competitor in Delhi. Once I went to that, which is that one industrial area. I forget the name of that industrial area. I have a luxurious 4,000 square foot area for my plant, whereas the same plant he is housed in hardly 1,000 square feet. Literally, वो बोलता है कि एक का ऊपर एक, but then what to do? He has to do that, and his layout is totally different from what I have. No, I have the luxury of group layout, which he doesn't have. But then he produces less variety, so helpful. So space utilization is important. Material handling cost is important. Lead time of the processes has to be taken into account for layout. Investment in work in progress, how much buffer you can keep between the one process to another. Movement between departments, utilization of resources, ease of production control, and number of ownership changes, like between shifts, one shift to another shift. If you have seen in a hospital, there are 3 shifts, and I've seen it's a beautiful system, especially I saw it in Apollo hospitals, where the 8 o'clock morning when the shift changes, they have a group meeting, a coffee meeting kind of thing. The supervisor plus all the nurses who are going out and the nurses who are going in are standing together with the supervisor, and each case is discussed and handed over. The whole process takes only about 10 minutes or so. But beautifully, it's like a pattern change, from one to other. So this is a change of ownerships. For a given job, what happens is when there is a job which needs, let us say, 2 to 3 days, and it is done by different people, but using the same facility, then the process owner himself is changing every 8 hours or 12 hours, depending upon the work. So that changes is something which is very important. Hand-holding, pattern changing kind of thing. So these are the measures and the basis of measurements for each one of them. You calculate this to get the best outcome. So alternatives for the design of layouts, process layouts, is qualitative methods, quantitative methods. Of course, I will not get into too much of details because today a lot of these are using, you get computer software for feeding in the data and then getting an optimum layout kind of thing,
So these are the type of software which are available at ALDEP and Core Lab, which are there. And then for quantitative method, there is a software called Craft, which is there. And there are many computer simulation techniques which are also there for layout design. Usually individual companies may not be having, but consultants who are there, there are many consultants who are process consultants. They will be able to help you in getting a process design. A qualitative method uses something, it's this kind of a matrix, it's called a house matrix, it is used in quality systems also, giving thing. So the terminologies which are used is, you put the absolutely necessary, essentially important, ordinary, closeness, unimportant, undesirable. For this department, this may not be necessary. For this department, this is extremely important. So you create a matrix like this, and then design the layout being on which is the optimum for use for all the departments. So this is a qualitative method. Quantitative method, as again we said, we talked about the center of gravity method, kind of thing, same thing which is used. You take into account the cost and the distance which has to be moved, the materials. You may say this may not be very important, but then day in and day out, year, month after month, week after week, when you do, you will feel that, so much of things are being wasted. Wastage of movement is one of the wastages. So there can be a mathematical programming to ensure that the least cost and movement is there. Several mass production systems are in operation today, right? So various sub-assemblies in mass producer need to be configured to match the production rate. Similarly, the final assembly stations also need to have the required number of resources at each station to meet the targeted demand. Sometimes, like when I'm, what comes to my mind is, in fact, I'm going for a inauguration of a plant by my friend on making machinery for cleaning. Clean Fix is the name of the company. It's a Swiss company. In fact, my first thing will be to see the plant layout. That is on 22nd morning is Wednesday, I think, next week. I'm quite interested, being an engineer, how the layouts are done. I'm sure he would have taken a lot of things into account. But the problem is, if he has copied the Swiss system here, sometimes it may not work, because the way we work here, the number of people we use here, the automation levels which are done in our production may be totally different from there to here. So blindly copying a layout of some, thing which is happening in the Western countries to here is sometimes doesn't work. Okay, so we have to look at our own thing. A product layout design seeks to identify the minimum number of resources required to meet a targeted production rate and order in which the resources are to be arranged. Here we talked about line balancing. You see, technique employed for designing the product layout is known as line balancing. Of course, I talked to you much earlier, but the product's layout has to be balanced. This is extremely, extremely important to ensure that there is an optimum output and equipment utilization is and manpower utilization is maximum. Line balancing trade-off is okay. I'll straight away. How are we fixed on time? Okay, we have another 10-15 minutes. The line balancing is a method by which the tasks are optimally combined without violating precedence constraints. What do you mean by violating precedence constraints? As I told you, input, process, output. Output of one is the input of the other process. You cannot do one before the other. It has to follow that sequence, anything. So combining without violating the precedent constraints and a certain number of workstations designed to complete the task. As I said, in some cases, you may need 3 workstations. Some may need 2, some may be having only 1. And depending on that, how do you balance the line? Key decision variables are production rate, cycle time, and the number of workstations which are interrelated. Cycle time is what, from the input to output. As I gave you that example, maybe one process takes 1.5 hours, the other process takes only 20 minutes. So 1.5 hours is the bottleneck, because if you want to bring the throughput to 20 minutes, then this 1.5 hours, which is actually 90 minutes, right? So 90 divided, by 20, that many number of stations. So let us say 5 stations, because 90, if you round off to 100, even considering since it is a critical job. So we need 5 workstations here to ensure that the throughput will become 20 minutes. So cycle time, production rate, etc. So solving the line balancing problem calls for striking the right trade-off between increased production and better utilization of resources. Cycle time is a ratio of the available time to the actual production rate, actual or desired production rate for that particular process. The entire process itself will have a cycle time that will be determined by the bottleneck process which is happening. So if you remove the bottleneck everywhere, then you will have a very clean, most efficient throughput for that particular line. In fact, this entire thing of line balancing and all that is also taught in by using Israeli method, called as the theory of constraints. That's an advanced topic on line balancing. It's called theory of constraints by Eliyahu Goldrath, an Israeli professor. We have used all that, of course. I'm just giving you since we are talking about cycle time and line balancing. So some measures of interest: actual cycle time is equal to available time by the actual desired production. Minimum number of workstations required is the sum of all this tasks divided by the cycle time. That, like we said, cycle time you want to be 20 and the task time is 90 minutes. So you can't have 4.5 machines. So you'll have to have 5 machines, the thing. So average resource utilization is sum of all the task time divided by the number of workstations into cycle time. Simple calculations. So a factory working in 2 shifts, say of 8 hours, produce 24,000 electric bulbs using a set of workstations. Using this information, compute the actual cycle time for the plant operation. There are 8 tasks required to manufacture the bulb. The sum of all the tasks is equal to 12 seconds. How many workstations are required to maintain this level of? So how would you do? So the available time is 8 hours, 2 shifts, because minutes into seconds, we have done that. Actual production is 24,000. Therefore, using the equation 8.2, which was earlier, 57,000 seconds divided by this many electric bulbs. So cycle time is required is 2.4 seconds. So every 2.4 seconds, one bulb has to come out. This means that the factory is producing a bulb every 2.4 seconds. So the number of workstations required is, there are 12 stations we saw into 2.5 seconds. So you need a minimum of 5 lines or workstations. Therefore, the task has to be split upon 5 stations, such that each workstation will have sum of task times, which is equal to 2.4 seconds. So many lines you must have to produce this. Example 2.
a computer manufacturer needs to design the assembly stations in a factory where the cabinet housing and the hard disk, motherboard and other accessories are to be done. The factory currently works for one shift of 8 hours. The task, the duration and their precedence relationships are very important. I said the precedence relationships are, this is the precedence relationship. Process A goes to B, C, D, E. B goes to F, C also goes to F, C also goes to G. This is the install speaker, correct relevant modules to motherboard and disk, install the controller, visually inspect and close the cover plate. Imagine a company like Dell or somebody who is producing, and in fact, one of the biggest problems in computers is there is multiple varieties. In fact, Dell is one of the companies, if you've seen or a thing, they customize your requirements. It's like you just mix and match your order based on what you want. So when it goes to them, they will have to make a process in such a way that all the requirements are come. And then for each of the processes, the time taken is this. So the total time taken from this end to H, unless you do parallel, what all things can be done parallelly should be done parallelly. What has to be done sequentially will be done sequentially, because you cannot disturb the precedence relationship. So that is how you make a layout. So here in this example, number of workstations required is 5. Design with workstations. Anyway, this is an example. Probably you can go through a little later because it will take a lot of time. Designing with 6 workstations. So designing of group layout, the principles are the objective of one of subdividing a universe of machines of a particular type and components into subgroups. Each subgroup of components form a part family and is endowed with a corresponding subgroup of machines known as machine groups. Group technology layout design is done in a systematic way. Machine component incident. Okay, we will not get into too much of this. Number of methods available for identifying subgroups of the cellular technology or group technology. These are all the methods. Too much of detail. Of course, the way it is done is a simple matrix format. What are all the machines which are available here? What are the components to be made using those machines if you do this? And it's very easy using the same matrix, like in your Excel sheet, you sort on, kind of thing. You give a command of sort on, you get it on a different way. Similarly, here you sort on BC, then you will get this relationship. Then you'll come to know that for doing all the components B and C, these are all the machines like we saw that, the components. These machines can do these components, you need these machines, whereas for these components, you need these machines, 111. Of course, here is a very simple example, they're given 111. If you do line balancing and then take cycle time into account, there can be multiple machines in some of these. This is a very simple example. Okay. Design of group technology. Read each row of the machine components. The same thing what we did. The previous one is explaining here. Rank ordering of the matrix. Again, it's an example. Here he has given an example of Lucas TVS of one-man multiple machine layout. See, this is something which is most desirable. Multi-skilling of manpower. Any process which you do,
if you are able to ensure that your employees are able to do more than one job, or sometimes even all the jobs, there is nothing like it. For quite some time in India, it was, the unions were fighting shy of this, and then, one man, one job, if you have heard, was the principle. But over time, managements, unions have realized, and even employees have realized, and management has been able to do that. How one man is able to take a job through different processes to complete the job. It could be a layout like this, a 4-way drill like here. The job comes here, the same person does this process, gets that process, comes to this, finishes the job and comes out. Ideal would be this kind of a thing, but of course the process time, the throughput will be the addition of each one of these processes. So again, it depends upon the type of product which you need, for it to be used. Some of these services, yes, you can do. Like if you go to your hospital and you want, before going to the doctor, these are all the tests which has to be done. In fact, I saw that in Narayan Hridayalaya, they assigned one person to us to monitor your movement from the time you enter. That first you have to go here, get your blood pressure checked, your weight checked, and this and that, and then you go to the X-ray machine, because each person's requirement is different, So they'll follow you through the entire process till you come to the final one. But the same person is there who is taking you. Of course, the processes are done by different people. Here, the process itself is done by the same person. So there are this kind of layouts which is possible. Advantages are there, disadvantages are there in this system. Okay. Now, coming to the service systems, the two important factors which influence service systems are the degree of customer contact and line of visibility. More problem when you have more contact with the customer, but then that is not avoidable in service. So the service provider has to be very careful, because each customer does not behave the same way as the other customer. Whereas in a product, when you are manufacturing, all products behave the same way. Customers don't behave the same way. So in a layout where the least customer contact is there will be most efficient. The more customer contacts are there, it becomes. That is why today also, you go to many places, they will give you, even in a hotel, better hotels, they'll give you a tablet and then make you to order, kind of thing. Only there'll be an assistant, probably if you ask him what is this, he may explain to you. But otherwise, if he has to read out everything and then you take a decision, it takes a long time. Some people may be quick in deciding, some people may not be. You go to a shopping mall, unless you're somebody you desire to ask, they don't come to you to help. In a multi shopping kind of a thing, you yourself take out things from the rack and then go to the output. The customer contact is important at the same time in service to ensure that your design in such a way that there's the least contact will be more efficient. If firms aim for high degree of customer contact, then customer convenience is of paramount importance. And firms may have to forego efficiency aspects of listening because customers take more time to design, right? So this is where the problem is. An increase in the line of visibility exposes more business processes to the customer, paving way for multiple opportunities for hazarding service quality. layout decisions are critical in such situations. So these two factors are very important in service systems. So we have come to the end of the plant layout thing. So what we discussed was that volume, variety, and flow. These are the three main factors which decide the layout of a plant layout or a service layout. What is the volume? How much of variety is there? And what is the type of flow which you want to design? Product layouts are usually for high volume, low variety situations. At the other extreme, a fixed position and a project layout are useful for high variety of situations. Product layout and process layouts are used in discrete manufacturing industry. They have several advantages and disadvantages which we have seen. Mid-volume and mid-variety manufacturing systems can benefit from a group technology or a cellular technology layout, as we saw the alternative word used. Quantitative approaches to design the process layouts typically make use of some of the measures of interdepartmental flow and material handling costs for assessing the suitability of a layout. Now, of course, we also saw that there are softwares which are available for designing quantitative design approach to layout. So these are the main things. Several computer packages, as we said, I just told you. I forgot there's one more slide. Product layout design seeks to identify minimum number of resources required to meet a targeted production rate and using line balancing. Group technology layouts are designed with the objective of subdividing the universe of machines and components into subgroups, and then these subgroups are then taken for final assembly, or maybe 3-4 into a final assembly. Two important factors that could influence the layout design problem in a service organization are degree of customer contact and line of visibility. So these are the highlights of plant layout. So we have finished here. Any questions? You can open up your. As I said, in Unit 4, there is one more thing which we have to do. I'll just, you want to know the syllabus, no? I'll just open up that. I'll just show you. 1 minute. Syllabus, yeah. Are you seeing the screen?
No, sir.
What happened? I came out of it. No, you can see now, no?
No, sir. So the first slide of the presentation only is visible.
अच्छा, 1 minute. उसको stop share करता हूँ और वापस अभी share करता हूँ अभी. I'll share again now. I'll just take you through the syllabus and then I'll share it also with you. Okay. See, this is the syllabus. Now you can see, no?
Yes.
Now we can see. So operations management and supply chain management.
Yes, sir.
Yeah. Unit 1 was introduction to operations management, which I took, and productivity also I took last time. Process configuration strategies, madam, taken yesterday.
Yes, sir.
Plant, out of, as I told you, I have only covered 2 factors governing the location of the plant and different types of plant layout. Material handling cover nahi kiya, but we'll do it. I'll do it in the subsequent thing, because I knew that this is a very large subject and it will take more time. But I'll be doing it. Don't worry. I'll complete it. Maybe when I do materials management, I will cover that part as a part of that. So materials management is a unit. Then operations planning and control. We also call it as production planning and control. But then now, of course, production PPC. Yeah, PPC. But abhi kya hai? Abhi operations bolte hain, because include service also along with production. This is a very important thing. Inventory management, inventory classifications management and things like that. Then network analysis, basically for it's a mostly a project for project management of projects, program evaluation and routing techniques, then critical path method, CPM, PERT and CPM, used for project management. Statistical process control, extremely important, especially in mass production and many areas, because this is again the basis for Six Sigma methodology, subjects. So this will be taken, including total quality management, which is an approach to quality, basically. Then a unit on environment, ethics, technology, and contingency, because today everything we are talking about sustainable development goals, all that, and talking of ISO 9000 for systems and ISO 14001 for environmental quality. Okay, and strategic planning and supply chain management, source, make, and move methods in supply chain. Then demand planning and forecasting, but I think this should have come earlier. Anyway, I'll talk to Rekha ma'am about it. Advanced sourcing strategy, logistics and distribution optimization, and supply chain finance, IT-enabled supply chain management. So this is the total for this particular module. Okay, this ko my abhi, I will send it to your CM.
So you could send it to our group.
Yeah, I'll send that, and today's presentation I'll send it to the group. Okay,
Yes,
please, before I get out from my seat, otherwise I forget.
No, sir, there's no hurry, but still.
No. Okay, see, I'm dealing with so many things.
Right, sir.
Yeah. See, for me, it doesn't take much for presenting, but since I do too many different things, so that is the startups mentoring is one of the main.
Yes, sir. So that means that you are a very multi-talented person.
So abhi kar deta hu. In another 10 minutes you will get both.
Yes.
I have to send you the syllabus and send you the today's PPT. Okay.
Yes, sure.
Thank you, sir.
Thank you, sir.
Yeah, I know, because it's a dry subject, but then I'll have to make it as interesting as possible.
No, sir. By going through the syllabus only, and it's quite promising. It's quite interesting to me.
Yeah. Okay.
Yes.
Right. Okay. Yeah. Right.
Thank you.
Thank you.
Thank you, sir.
Says, can I sit?